Right. When we talk about trigs. Tell me something. What comes to mind?
Triangles.
Anything else comes to mind?
Different types of triangles.
What is that?
Different types of triangles, so like right angle triangles.
Okay, like right angle. I like that. I like that. Right angle triangles. Anything else?
Different types of angles,
Okay, what is different types of angles we have?
like obtuse, acute, right angle, and stuff like that.
All right. Oh, I'll share my screen. When we encounter trigs, right? We are going to see a lot of right angle triangles to begin with. A whole lot of right angle triangles. And we need to know the formulas associated with these right angled triangles. You're supposed to be familiar with Pythagoras theorem. Yeah? Pythagoras theorem is applied to all right angle triangles. And all right angled triangles, they have the name, they have three sides and each side has a name. The longest side is the hypotenuse. The other two sides are called the opposite and the adjacent. And the opposite and the adjacent, take note from now, they can change. So in this diagram, this side, if I name the triangle ABC, AB is my adjacent. The opposite is AC. That is subject to change. Sometimes AB could be my opposite and AC could be my adjacent. And we're going to learn why will they change, all right? But Pythagoras theorem states, Pythagoras theorem, you all would have learned that as A squared is B squared plus C squared. I would have showed you all in form 4 that is the hypotenuse squared is equal to the sign here, THEOREM, colon, hypotenuse squared is equal to the opposite square plus the adjacent square. Good. And if I were to rearrange, I don't know how to rearrange it. Okay. Sometimes you'll have to learn how to calculate the hypotenuse. Sometimes you'll have to calculate the opposite. Sometimes you'll have to calculate the adjacent. Well, the hypotenuse is just going to be the square root of the opposite square plus the adjacent square. If I were to rearrange, I will put or. If I were to rearrange and I make opposite the subject of the formula, I will move the opposite across and I'll move the hypotenuse across. And I'll end up with opposite squared is equal to the adjacent squared. Sorry. I'll just move the adjacent to make opposite the subject of the formula, right? So I'll remain with positive numbers. When I move across the adjacent, I'm going to get the hypotenuse squared, take away the adjacent squared is equal to the opposite squared. Yeah. Again, if I want the opposite alone, I'm going to say the opposite is going to be the square root of the hypotenuse squared, take away the adjacent square. Or if I want to make the adjacent the subject of the formula in my original equation, I will just move across the opposite and I'll end up with the hypotenuse squared minus the opposite squared is the adjacent squared. If I want the adjacent by itself, the adjacent is going to be the square root of the hypotenuse squared minus the opposite squared. And this is square root of that whole thing. So you're working out whatever is underneath the square root sign, and then you're punching the square root of that. Let's do an example. If I have a triangle, a right angle triangle, and that is the only way you can know it's a right angle triangle, with the right angle symbol. Cool? I have a right angle triangle, and it says that this side is 3, and this side is 4. I want to know what's the value of the missing side. The side opposite the right angle is always the hypotenuse. Always. So the missing side here, what could be his name? What is the missing side over here? Come on, quickly.
The hypotenuse. Yeah.
The hypotenuse. You're saying that? So I want to figure out what the hypotenuse is. I know the formula states the hypotenuse is equal to the square root of the opposite squared plus the adjacent squared. For Pythagoras' theorem, any side could be the opposite, any side could be the adjacent. Only for Pythagoras theorem. So I could say, well, I could say let 3 be the opposite, and then let 4 be the adjacent. That is the square root of 9 plus 16. That is the square root of 25, which is 5. Yeah? If we do our next example, this time, obviously, the missing side is going to be either the adjacent or the opposite, either or. All right? Next triangle here. Right angle here. Let me say I have 10 and 8. Where's the missing side?
The adjacent.
The adjacent. The missing side could be the opposite if you wanted, right? If you wanted, right? So because I'm using Pythagoras' theorem, it don't matter, right? So you could use either this one or this one, all right? Justin say, well, let me consider that to be the adjacent. The adjacent is the square root of the hypotenuse squared. Take away the opposite squared. Now, do take away the 10 from the 8, get 2, and the square root of 2 is, this is the square root of 100, take away 64, which is the square root of 36, which is 6. Good? So once you have a missing side, just know which formula you're using. These two formulas can be used interchangeably. All right, meaning it don't matter which one you pick. All right, it don't matter which one you pick. Now, try this one. I'll give my question as quickly as possible, right? Calculate the length of the missing side for me. I'm not going to give her the nice numbers to work with this time. 6 and 9. The missing side will be what in this first case?
Hypotenuse.
Hypotenuse. So use your hypotenuse formula. And for this one, we have 11 and 6. The missing side in this case could be either the opposite or the adjacent. You could use either formula you want. All right? Give me the length of the sides in these cases. Your square root is found by pressing second function on my schema calculator as well. Your square root is found by pressing second function and x squared. That is the square root. So go ahead. I'll wait for answer. Right, give me a sec. Come back now. Yeah, gents. Talk to me. We have Nishan. What I get for the hypotenuse in the first one?
10.81, sir.
10 points.
81.
Everybody could confirm?
Yes, sir.
Cool. Well, somebody might have called this the opposite, and next man would have called it the adjacent. Yeah. At the end of the day, what you all got for the length of this side?
9.21.
This is the opposite slash adjacent, right? If you want to call it either. 9.21.
21.
I'll look at confirm with that one.
Yes, sir.
That's a
Cool. So whenever you see a right angle triangle and you see the triangle have two sides, Pythagoras' theorem. Cool. Now, let me talk about the angles inside of the triangles now. The Pythagoras theorem is one formula that could be applied to right angle triangles. Our next formula we could apply is, well, three of them: sine, cosine, and tan. So sine, cosine, and tan. These fellas always have to have an angle next to them. And we use theta to represent an angle. Cool? Sine has a relationship opposite over hypotenuse. Cosine has a relationship adjacent over hypotenuse. And tan has a relationship opposite over adjacent. An easy way you could remember it is by using the acronym SOHCAHTOA. So, ka, toa. You all could remember this, right? Good.
yes, sir.
And now the opposite and the adjacent could change because I'm starting to use angles. Depending on the angle we're using, the opposite and the adjacent are different sides on the triangle. So let me see how to label the triangle properly, right? So we're gonna have a big triangle. Right angle triangle. Everybody comfortable with that? All right, so we're gonna learn to label a triangle. Let me say this side here, this angle is theta, and this angle, let me represent this angle as x. Cool. The sides are going to be A, B, and C. And if I am labeling the triangle, the side opposite A is little a. The side opposite B is little b. And the side opposite C is little c. Cool? So the same concept will apply if the vertices are labeled PQR. We just use the common P, common Q, and common R to represent the sides opposite them big letters. Cool? You don't have to do it, but it makes life a little easier when we do it. Now, based on some definitions, and I wouldn't give, like I said, I just tell you all you how to do. If I am using theta in a calculation, this is theta. Agreed? If I use in theta, opposite means it's opposite the angle. Yeah? So this side is opposite theta. Or look at argue with that. Yeah? This will always be my hypotenuse. And by the process of elimination, this had to be my adjacent. Yeah? That is if I use in theta. If I use in x, let me use a different color. If I use in x, same principle applies. The side opposite x is going to be the opposite. That is if I use in x. Homeboy here going on always be my hypotenuse. Yet again, the process of elimination states that this is my adjacent. So depending on the angle I'm using, the opposite and the adjacent, they can change. I can only use one angle at a time in our trigonometric ratio. These three things here, this, and this are trigonometric ratios. I can only use one angle at a time. Where's our wrong here? Cool. Now, let me actually do an example and give some numbers and letters and things to the triangle now. Let me do an example. That sound good?
Yes, sir.
30 degrees. 6, 7. Cool. 30 degrees and 30 degrees and 6. 60 degrees. 30 degrees, 60 degrees, A, B, and C. Cool. I will answer something here. Everybody. If I use any 30 degrees, what's going to be my opposite? If I use in 30 degrees, what's going to be my opposite?
C.
C, because C is oppositely 30 degrees, correct? A is my hypotenuse, and B is going to be the adjacent. Yeah? Change our plans. If I use in 60 degrees, what's going to be my opposite?
B.
B, because B is oppositely 60 degrees. Again, A is my hypotenuse, and C is going to be my adjacent. So I'm going to complete the three trig ratios, firstly, using 30 degrees, secondly, using 60 degrees. All right? I'll have sine of 30 degrees is equal to opposite over hypotenuse. Cosine of 30 degrees is adjacent over hypotenuse. And tan of 30 degrees is opposite over adjacent. Yeah? I'll get that so far. Dr. Man.
Yes, sir.
All right. I will help now. As quickly as you can, what will be sine of 60 degrees is opposite, same thing, it will still be opposite over hypotenuse, but what's going to be the opposite when I'm using 60 degrees?
It'll be B over A.
B over A. Good. What about cosine of 60 degrees?
C over A.
C over A, yeah. And what about tan of 60 degrees?
B over C.
B over C. Everybody is comfortable with that? Thelma.
Can you go over it one more time?
All right. So sine of 60 degrees, sine will forever be up here, opposite over hypotenuse. Cool? Forever. And ever, and ever, and ever. If I using 60 degrees, what's my opposite?
B.
If I using, right, give me a second, huh? Sorry about that. Yes, Justin. So if I'm using 60 degrees, you confirm with me that the opposite is B.
Yes, sir.
So sine theta, well, sine 60 is going to be opposite, which is B over the hypotenuse, which will always be A. Yeah? The hypotenuse is always opposite the right angle. Always. Right? Always. Cool? If I use 60 degrees, what's going to be, well, we already established that 60 degrees, if I use only 60 degrees, this is going to be my opposite. This is going to be my hypotenuse. So homeboy here going to be my adjacent. Cosine says that is adjacent over hypotenuse, which is the adjacent over the hypotenuse. C over E. See it? And well, should I explain the tan as well? Oh, you understand?
I understand now.
Good. So now time to start rearranging some things, right? Before I do that, I want to make sure all you're comfortable. I want all to tell me sine, cosine, and tan of the angles. Let me say I have 55 degrees and I have what this could be 25 degrees, and I have P, R, and W. I want somebody tell me, take your time and do it, what is sine of 25 degrees and
Let's
what
say
is
it's 35 degrees.
35?
35 degrees. Yeah.
Oh, yes, it'll be 35, yes. Tell me what is sine of 25, what is 35, what is sine of 55, and then all I get start, all you know what coming, tan of 35, tan of 55. We go to the cosine one time, yes? Cosine of 35 and cosine of 55 degrees. Right, so somebody volunteer yourself. Tell me what is sine of 35 degrees based on this triangle. Come on. Anybody?
So W over R.
So sine of 35 will forever be opposite over hypotenuse. My opposite is opposite the angle, which is W, and my hypotenuse is R. What would sine 55?
P over R.
P over R. Yeah? Because when I use in the 55, P opposite. Yeah? Justin? Cos 35?
W over
Take your time.
P.
Cos 35. Which way is cosine? Up here. Adjacent over hypotenuse. Where's the adjacent if I use in 35 degrees? Right, I'm asking a different question. What is the opposite if I use only 35 degrees? What, he looking like he's sticking? Oh, the man just very good at staying still. What do you feel? He's take for it?
So Jacob told me his PC crashed.
Oh Lord, Jesus Christ. All right, so sit down here, help for the man. Where's cosine of 35?
E over R, sir.
P over R.
R.
What is cosine of 55?
Yeah, again, sir.
How you mean?
Hold on, sir.
Shivan, you on the last one. Tan 35 and tan 55. Tell me any chat. I know you don't have a mic. In. Yes, Iran. Waiting. All right, here. I'm just checking something here. No, come back. We go let him handle the last one.
Sorry, well, that's my PC crashed.
Nice small thing. You know why it crashed?
I think my RAM got used up. Like, had apps running in my background and I could use it up.
What app do you have running in your background? How much RAM you have?
16 gigs. But like, this doesn't usually happen though. It just randomly started happening. Like the
what
only
apps?
thing I had,
Hmm? All what apps will be running in your background?
the only thing that was like running in my background was just my browser
Chrome?
with Zoom and stuff. No, Microsoft Edge.
Edge don't pick up much, don't use much RAM. Yeah, let's check that, right?
Yeah,
I will show you how to check it after.
thanks, sir.
All right, you're seeing the screen, right?
Yes, sir.
All right, so sit down, help you with the first piece. Help me with cosine of 55, right? So I was asking the question, if it is you see in trouble, identify what, and you could tell me what's the opposite depending on what angle I'm using.
Yeah,
What's the opposite if I using 55 degrees?
the opposite. That would be P.
P. Yeah? What could be the adjacent?
W.
That's if I using the 55, right? And
Yes,
this
sir.
could be my hypotenuse, correct?
Yes, sir.
So tell me what's cosine of 55. We had the formula for cosine of 55 up here. What's the adjacent and what's the hypotenuse if I using cosine 55?
P over
P over
R.
R, you sure?
W.
Read this for me. Cosine theta is adjacent over hypotenuse. Read it aloud for me.
Cosine theta equals adjacent over hypotenuse.
Good. What's the adjacent in this triangle? If I use it.
W.
What's the hypotenuse?
R.
See it? W
I
is the
think so.
adjacent and R is the hypotenuse. Adjacent over hypotenuse. See it?
Yes, sir.
All right, help me with tan 35. Tan 35 is opposite over adjacent. So if I use in 35 degrees, I'm rubbing off this, rubbing off this, rubbing off this. If I use in 35 degrees, what's going to be my opposite?
W.
What's going to be my adjacent?
P.
What's going to be my hypotenuse?
R.
Tan says opposite over adjacent. Where's the opposite over adjacent?
W over R.
Adjacent.
Not W over P.
Going tan 55 now, right?
Yes, sir.
I'm using the 55 degrees now, correct?
Yes, sir.
Rubbing off opposite, rubbing off adjacent, rubbing off hypotenuse. If I use in 55 degrees, what's my opposite?
P.
What's my adjacent?
W.
What's my hypotenuse?
R.
Tan says opposite over adjacent. What's the opposite?
P.
What's the adjacent?
W.
See it?
Yes, sir.
Good. So we're gonna start to do we're gonna do a calculation, right? I have about 10 minutes to tell you before I had a bus out. Oh, before we do a calculation, let me learn how to rearrange something, right? Every single time you're going to have something that looks like some trig ratio. So I'm gonna put trig is equal to something. I put A to represent the something over something. I put D, put A1. All right. So it's either sine, cosine, tan is equal to some fraction. Agreed? Tell me if I agree with that.
Yes, sir.
Yes, sir.
All understand what I'm saying here, right?
Yes, sir.
I want to try and rearrange this a bit. Everybody knows how to cross multiply.
Yes, sir.
Yes, sir.
So all I know, if I have A over B is X over Y, this is how we just cross multiply, correct? And I
Yes,
get
sir.
AY is BX, correct?
Yeah.
I'm gonna show you a trick. You don't have to cross multiply on the two denominators. If you want, you could do it on one alone. And I could get AY over B is equal to X if I wanted. If I wanted, I could have cross multiply here alone. And I get A is equal to BX over Y if you wanted. Cross multiplication don't just work from numerators going up to denominator. I could have sent the A down here if I wanted. And I get 1 over B because the A moves. 1 over B is X over AY if I wanted. All right. So you're not forced to cross multiply your both denominators by the opposite numerator. You're not forced to do it at all. So if I had something like this, sine of 24 is equal to 16 over A. Let me start simple. A over 16. This could be a potential equation we could get from a triangle. And
Yes, sir.
I want to figure out what A is. So I could just send the 16 above and I get 16 sine 24 is equal to A. I hit a little cross multiplication using only one of the crosses. Yeah? And you're well within your right to do that. So cross multiply the summa. Cosine of 22 degrees is equal to X over 11. Somebody tell me what X will be equal to.
So 11 cosine 22 degrees.
11 cosine 22 degrees. Doing the next one here. If I have tan of 42 degrees is equal to b over 2, what will be b?
2 tan 42 degrees.
2 tan 42 degrees. Everybody understands that?
Yes, sir.
Good. That is one particular case, right? So I can rub off this cross multiplication thing. When you're watching back the video, make sure and take down all the notes. Cool?
Yes, sir.
That is one possible calculations we'll have to do. The next possible calculations we'll have to do is if the unknown is now on the denominator. So same case, sine 24 is equal to 16 over 8. We go how to cross multiply still. Instead of cross multiply, I'll get a sine 24 is equal to 16.
Yes,
Just like
sir.
how we multiply the 16 across on this side here, I multiply the 11 across on the side here, at the 2 across on the side here. This time I'm multiplying the a across on the side here. Can you confirm that?
Yes, sir.
I want to get a. And from now until forever, it's the same thing, rinse and repeat. Same method I'm going to show you here. A, I want to get rid of this, correct? I want a by itself. To get rid of sine 24, I'll have to divide by sine 24. Or, if I wanted, and this might be a little easier, sine 24 is 16 over a. Switch them. A is 16 over sine 24. Same thing. You see that?
Yes, sir.
Let me do an next example. Cosine of 22 is equal to 11 over x. Tell me what x will be equal to.
Eleven over cosine 22 degrees.
11 over cosine 22 degrees. If I have tan 42 is equal to 2 over b, what will be b?
2 over tan 42 degrees.
Yeah?
Yes, sir.
2 over tan 42 degrees. I'm going to do a question. Easy question. Right angle, 75 degrees, 11. Yeah. They give my angle, I want to use it. Cool.
Yes, sir.
If I use in 75, what's going to be my opposite?
B.
B.
B. A.
So
B. Yeah, this side here, he named AB, he named AC, he named BC. Cool.
Yes, sir.
So homeboy going to be my opposite. What's going to be my adjacent?
AC.
What's going to be my hypotenuse?
BC.
So if I were to label the triangle, you're going to be little b, correct? You're going to be little c and you're going to be little a. Yeah? The side opposite a is little a, the side opposite b is little b, and the side opposite c is little c. Cool?
Yes, sir.
Right. And I will have to leave all to do this on all your own, right? I want you guys to tell me the 25 degrees, correct? No, 15 degrees. Correct?
Yes, sir.
I want Olia to complete sine 15, cosine 15, tan 15, sine 75, cosine 75, and tan 75. So we have 6 to do, right? Depending on what time I come back, I'll do the corrections for it, okay? But all you're doing is for me now. Figure out what the relationship is here. It's something over something, right? Cool? Something over something. We know the 3 relationships here is this. I'll copy this and I'll bring it down for you guys to get a reference here, right? The 3 relationships there. Tell me what sine 15, cos 15, tan 15, sine 75, cos 75, tan 75 is. And tell me which one has one unknown in it. Meaning I just have one variable in it. All right?
Yes, sir.
I understand what I have to do.
Yes, sir.
I will send this on you, right? I'm gonna send it on you. In case anybody get disconnected and can't come back. Cool. All you have that there. All you know what I have to do. Yeah?
Yes, sir.
Yes, sir.
I'll put it there just in case we get disconnected. I might take a little longer than half an hour. So like I said, depending on what time I come back. So what all I could do, when I get the answers, all right, send a picture of it on the group. I have data, I could check it when I go, wherever it is. And I'll give all the feedback one time. All right.
Yes, sir.
And on your solutions, circle, like make it known. Make a big circle over it, stating and telling me, yo, sir, this one has one unknown in it. Or this one is the one that has one unknown in it. Cool?
Yes, sir.
Nice. So I'll mobilize, do that for me. And send the solutions on the group. I'll give you all feedback. Depending on what time I come back, we will continue. Good?
Yes, sir. No worries.
Yes, sir.